Hello, good evening. So welcome to our final video on biomolecules. So this is our fourth video and we're going to talk about proteins, one of the most complex of all biomolecules. Okay, and the function of proteins is to provide the expression of the genes we found in nucleic acids. So they provide transport, they can provide structure, they are catalysts in form of enzymes, for example. Okay, so we're going to start with, remembering our dear friend, the nucleic acid. So hopefully you remember this mess. Okay, so we talked about and we ended up here that three of these somehow is some sort of information. Remember, this is our DNA. Okay, so when we start with DNA, a double helix, okay, there are some enzymes that are in charge of copying that information into messenger RNA. Okay, why are they making a copy? It's like if you go to a rare bookstore, you can't really use the real book, okay, to make cuts, to go ahead and highlight, for example. You need to make a copy first, and then you can highlight, and then you can cut, and then you can do whatever you want with the copy. The same with DNA. This is the most important piece of info, the brown one. Okay, you don't want to mess that one up, so we make a copy every time we need a certain gene. Okay, the gene is our copy. So this process from DNA to messenger RNA is what we call, transcription. Okay. Well, once it's in messenger RNA form, okay, our body can do some things with messenger RNA by itself, but it mostly is interested into its expression, okay, which is converting it to amino acids. So ribosomes carry on this function, and every three of this gives the clue to the ribosome which amino acid is the one that is joined. So when we are having the translation of, okay, RNA, messenger RNA into amino acid, we call and we say it is a translation. Okay, like if you're taking that copy, okay, which was originally in German and you put it in English, for example. Okay, so now this is where we begin in this section. Okay, this is our most important part because, this is our starting point. So here, amino acid chain. So let me show you. How does an amino acid look like? Okay, an amino acid looks like this. It's an amino group and a carboxylic acid. So has an amino, NH2, a carbon with a side chain, okay, the R, and a carboxyl group, this one, okay, carboxylic acid. So it's always an amino, a carbon, and a carboxylic acid, okay? So where does the magic happen? Where does the important part happen? What is going on here when these two are joined? Okay, well, if you know a little bit about organic reactions, you will see that a reaction can happen when you have a carboxylic acid and an amine. What is going to happen is, we're going to produce some water. In the process, it's condensation because water is produced, H2O, okay? And a bond is going to be forming. So what is the bond that's going to be formed? If these two join, then the bond will be this one in blue right here. Okay, how do we call this? This union is called a peptide bond. Therefore, if you have many of these occurring, okay, it's going to be a peptide chain. All right, so for example, this plus sign, okay, if you had amino acid, okay, mass and plus another amino acid, this would be the peptide bond. Okay, this is in a more descriptive way. These R groups, okay, there are 20 different R groups, all right, 20 different side chains, out of which, okay, all of them make life. So let me show you a little bit more about those R groups. So I have a few examples over here for you, okay? What can you notice about these R groups is that they all have this repeating structure. Amino, carbon with a side chain, and a carboxylic acid. So this is the one we've seen before, okay? What's different is the R. So this is what the R is. Okay, sorry. There. What the R is about, okay? All of them have that same repeating structure. Amino, carbon, carboxylic acid, and an R group. Amino, carbon, carboxylic acid, and an R group. Okay, now what is peculiar about this is that some R groups are mostly carbon, some have oxygen, some have electric charges, and what you need to identify, well, if it's mostly carbon and hydrogen, it is going to be nonpolar. If it has oxygens, nitrogens, etc., it's going to be polar, and if it has, okay, extra electrons or extra protons, it's going to be electrically charged. So this is what the R is about, okay? Don't forget. Now, let's put a lot of amino acids together. So starting from here, now let me show you one example of a chain. Here we go. Okay, what's going on here? Okay, let me turn it around. It goes like this. So a peptide chain, if you notice here, you have amino, carbon with a side chain, carboxy. Okay, amino, carbon with a side chain, carboxy. So here is our peptide bond. Okay, another peptide bond, another peptide bond. Okay, so this is a peptide chain, the backbone. How many amino acids do we have? Well, you would have to count each one of them. So, advice, count these. But only, okay, the ones in your backbone, not the ones in the radicals, okay, or in the side chains. There are two important parts you need to identify in this molecule, and it is the amino end and the carboxy terminal here, okay, amino end and carboxy. Alrighty, now each of the following, so remember our radicals from before, okay, these we could identify as here. All right, those are our side chains, our R's. All right, well, good luck with this endeavor, okay? As you know, okay, proteins are of no use to our body in this form, okay? They need to fold, they need to become useful, which is in the folding when they become useful. Okay, if you change one of these amino acids, it folds differently. There are 4 different stages: the primary structure, secondary structure, tertiary, and quaternary structures. Primary structure is just a chain of amino acids, like this one. Secondary structure is when those chains start making, okay, you have interactions among the backbones and you make alpha helices and beta sheets, okay, interacting. Tertiary structures is when you have helices and sheets and helices and sheets. They are all interacting. Okay, quaternary structure, let's say you had 2 of those combinations, helix, sheet, interacting. Okay, and then you have another one. Okay, almost identical. Sheet, helix, etc. Okay, so these 2 are now interacting. That would be the quaternary structure. Now, if you heat these up, any of these, what's going to happen is they're going to return to their primary structure. That is called protein denaturation. Okay, that is, for example, when you cook an egg. What happens when you cook an egg? Well, it goes from clear to white. So you unfold the protein, you denature it. Okay, well, I hope this is of some help. Okay.